from 5.1 day 1. This isn't exactly an example, but it is a side note to help you out with certain things that involve the squared ratios. We've talked about the squared ratios that they're used with Pythagorean identities most commonly, but there are also certain cases where you can change like a tangent into a sine and cosine to use that most important method about changing all to sines and cosines. So I want to highlight that just a little bit here by referring back to our trig identities at the beginning. So I want you to realize or remember that our trig identities at the beginning, notice this one that has tangent equals sine over cosine. So we know that identity from the quotient identities, that tangent is equal to sine over cosine. But I also want you to notice here then in this example that tangent squared is equal to sine squared over cosine squared. So what I've essentially done to this quotient identity is I've squared each piece. I've squared both sides of the equation, and I'm saying that that is an okay thing to do. Similar with secant squared equals 1 over cosine squared. That comes from a reciprocal identity. That comes from the reciprocal identity that says that secant equals 1 over cosine. And again, we just ended up squaring both sides of that equation. 1 squared is still 1, so that's just left as it is. And then that equals the same thing. So these, when you square something, you can also extend it to the other properties related to that particular trig ratio. And then this last one here, just to kind of reiterate what that all means then, if we have tangent squared divided by sine squared, let's see what that would look like in this case. So if we go tangent squared divided by sine squared, that means, well, we can replace this tangent squared with what we just looked at up here. I can replace that with sine squared over cosine squared. Okay, so that's the tangent squared part. Sine squared is on the bottom here, and remember that when I divide by something, it's the same thing as multiplying by its reciprocal. So now I can say sine squared over cosine squared, that's the top, multiplied by the reciprocal of this one, 1 over sine squared. Well, now that I have it set up like that, you might be able to see that I can cancel out sine squared on both the top and the bottom, leaving me with 1 over cosine squared. And like we just talked about in the middle up here, 1 over cosine squared is the same thing as secant squared. So if I wanted to, if I was looking to simplify this without having any fractions, I could again turn this back into secant squared. So this is just a way to show you that a lot of things here, the identities work together, and especially the squared ratios, they definitely work with a lot of the different reciprocal and quotient identities.